when it's like 5 seconds to try stuff out, you just try out way more things. The person who made The Root Trees Are Dead had the same idea and saw the same promise in the open text box kind of thing and just found a way better implementation for it. All you would need is one line somewhere in your code to say, hey, here's the function declaration for the function I'm about to call that I got back in this pointer, and it looks like this. And by the way, it's a C function, not a D function. Like, the biggest advice that I would give is like, start programming.
Hello everyone, and welcome to Wookash Podcast. This time I'm joined by Louis, who left AAA to pursue his dream and make an indie game from scratch. He's an incredibly talented engineer. He's making a 3D puzzle game from scratch just by himself. It's called Art of Reflection. Check it out on Steam. Wink, wink. Demo available now. Wink, wink. And if you think that making a game from scratch that is 3D puzzle game is not enough, he managed to top that. Let me tell you, Louis is making this game in the programming language. So you just gotta listen to this guy. So paint the picture for everybody who is listening. What is Art of Reflection?
Yeah. So The Art of Reflection is a first-person puzzle game about basically warping through mirrors. It's kind of if you've played either like Superliminal or Viewfinder or Portal or kind of similar first-person games like that, based around like a mind-bendy central mechanic. It's kind of one of those, just different. Really, like, if you wanted to sum it up in 3 words, Portal but mirrors gets you pretty close. Turns out like the underlying tech is pretty similar between them, but that's a separate thing. But yeah, it's basically like I've grew up playing a bunch of these games and love them and try to find out all of the different ones that I can, even some of the like the niche ones that aren't as well known. And I have a real soft spot for them. And so when the time came to try to build my own thing, I was like, well, why not try and do this?
What are the niche ones?
So like a recent one that I've played, it's not quite the same, but it is a first-person puzzle game, is Chroma Zero. Which is, it's like, the best way I can describe it is like taking this kind of discovery first structure of Outer Wilds and like distilling it down to its root. So it's like much smaller in scope and a more kind of constrained game than Outer Wilds is, but has the same loop of like you're thrown into a world that you don't understand and the world is not built for you and you have to like navigate around and learn the rules and understand what's going on. It's all like first person 3D and you're just like running around this kind of like sort of like difficult to understand environment, at least at first, and then you slowly come to understand more and more how it works and then are able to like use that to your advantage to do what the game wants you to do.
Nice. Okay. And the Art of Reflection is using an odd programming language.
Yeah. So D is definitely not the usual choice for this sort of thing. So when I started this, I worked in AAA for 5-ish years or so, kind of during university, like doing kind of co-op placements, and then after university as well. And those were all in C++. Those were like, custom in-house engines in C++. And so when I finally like made the decision to like, I want to, try and do the indie thing, and I'd saved up a bunch of money. And so I quit my job and I was like, okay, I'm starting from scratch. I'm building my own thing. I mean, I have the option to try any of the existing engines, but I was kind of like, so on them. I'd use them in game jams. Like, it's true that they give you a bunch of stuff for free, but there's like, you've probably had other people come on the show and talk about the engine versus not engine debate and other stuff. But in the end, I ended up going for my own. And I had, when I worked in industry, I was lucky enough to I joined the rendering team there because they needed people and they were just like looking in-house to see if anyone wanted to do that and was willing to learn rendering. So I didn't know how to do anything at all, other than like I knew what a normal map was because I'd fiddled around in Blender before. But like I didn't know any of the programming side, and they're like, sure, that's fine, just like sit down here and learn, and as long as you learn it, it's fine. And so I got paid to learn rendering programming for 3 years, which was an amazing opportunity. And I'm super lucky I got to do that. And it meant that coming out the other side, like if I wanted to build my own 3D renderer, I knew how to do it. Because we literally rebuilt the renderer from the ground up in the 3 years while I was there. And so I decided to do that. And I kind of started poking, like I'd originally thought I was going to go 2D when I started. because that is the prevailing advice for indies, and it's honestly probably still good advice for lots of people. Just like keep scope small and stuff, and like so that's like don't necessarily dismiss that out of hand. But I had the chops to be able to do a 3D render and to be able to like try weird stuff with it. And so I decided to do that, and it took a while, but it wasn't so bad. Um, as for the like, because I was starting from scratch, I was like, I had the choice of language, which is something you very rarely get to do. Like normally you're just locked into C++ because that's what you've been doing for the last 20 years. And so even if we were rewriting our renderer from scratch, it's not like we're rewriting it in D and then doing interop between C++ and D. That would be so much complexity for no good reason, and no one would ever buy into that. But I was starting from scratch, so I had the opportunity to just do whatever. And so I went through a bunch of different languages. Jai wasn't out yet, unfortunately, at the time. This was like 4.5 years ago, or like it wasn't publicly available to me. I was watching it very closely, and it was one of my front runners, but it wasn't ready. And I was like, I can't wait for it to be ready. So I need to pick something now. And I looked briefly at Rust as well, which is really promising. I really want to try out Rust a little bit more because I can't speak to it in as informed a way as I'd like because I just haven't used it enough. But my big worry with it was that it was going to force me into a way of programming that I didn't like because of it. Like it tries to verify a bunch of stuff at compile time, which is a really cool idea because like memory bugs and stuff are a bane on C++ programmers' existence, and it's a huge problem. And so a language that tries to solve that problem, that's like a worthwhile problem to try and solve, to find ways to catch the bugs that I have written many times in the past and that have been a huge pain to figure out. um, but in order for it to be able to analyze things at compile time, you have to write things the Rust way, like in a way that the borrow checker can understand, and the way that like fits with their model. And if you want to do anything different, if like I just like a different structure better, or if I like for performance reasons I need to do it a certain way, um, like I had worries that Rust wasn't going to let me do that, or that if I wanted to do that, I'd have to put everything inside a giant unsafe block. And then at that point, what's the point of using Rust? Whether that fear is fully warranted or not, I don't know. I would have to use Rust more. It could be that I'm talking out of my butt and it's not actually true, and Rust would have been fine. I'm not sure. But from the little bit that I looked at it, that was my fear. And the big thing that grabbed me about D was that it was very like it allowed you to program in a bunch of different ways. So like for example, it's garbage collected by default, which normally is a no-go for games. But it also lets you do manual memory management, and you can just like pick which one you want just in the code. Like they're both available to you. And if you don't allocate into the garbage collector, it never collects, because it only collects if you allocate, and then it looks and it decides, oh, now's a good time to collect. So if you
Okay.
don't allocate, it never collects. And so I use the garbage collector basically as like global memory. So in startup, I allocate a ton of things into the garbage collector. And I use it for like debug tools and for my editor and in-game editor and stuff like that, where I don't really care about, like uh, a 50 millisecond hitch is not a big deal when I'm editing. It's a big deal when you're playing the game. And then for like minute to minute runtime code in the game, I don't bother with like I just don't use the garbage collector at all. I completely opt out of it, and I do my own memory management, and so it's not a problem. Like it won't collect because I never use it. And then, like for example, if you die and restore from a checkpoint, like the screen goes black for a second when that happens. I do a garbage collection right there because I'm just like, hey, whatever. Like it's a hitch anyways. Who cares? Just quickly do a garbage collection, then bring the screen back up, and then once you're up, no garbage, no, don't touch the garbage collector. Do your own stuff. Um, and I can go into memory stuff later if you want. But there's some other tricks that I use that are like really common in games to be able to like deal with memory in a way that isn't totally crazy, because it turns out most of the use cases are not actually that complicated in games unless you're making GTA, and I'm not, so it's simple. um but like yeah, I really like that part about D, where it gave me a lot of flexibility in what I wanted to do. It was very familiar to me coming from C and C++, just with a lot of the annoyances that I had fixed, which was really nice. So like, C and C++, one of the things is that the include system is really old, right? It's basically copying and pasting code wherever you write include. And that sucks. You have to deal with forward declares and cyclic includes, and like the compiler gets slow if you put templates in headers because it's just copy pasting them everywhere basically, and running the templates. And there's all sorts of problems that emerge from that. And D uses imports like any modern language does these days, and problems gone. So you just don't even worry about that. I can literally like cyclically import stuff, and as long as I literally don't have a cyclic dependency between two things that actually need to know what each other are, then like I can have A import B and B import A, and they just use different parts of each other, and it's no problem. It just resolves it all. And so there's like there's a bunch of things that were like a bunch of upkeep I would do in C and C++ that I don't do in D anymore. It's just handled for me. I don't have to maintain header files. It's just done for me automatically. If I want to see a header at a glance, like Vim has features where you can just like collapse all your function definitions, and so you can see at a glance what your header looks like. But there's no need for me to maintain two separate files.
Okay.
Um,
Okay. Tell me a little bit more about the D language in a sort of agnostic way, and then
mhm.
we're gonna talk about D language for game from scratch.
Sure. Yeah.
So paint a picture of the D programming language for a person that is like familiar with programming, but can come from any point of view, sort of.
Yeah. I mean, like the pitch that kind of worked on me, which almost sounds sort of mundane, is that like C++ or like C came out in what is like late 60s, early 70s, and C++ in the early 80s. And you would think that there's been a bunch of innovation in language since then, and yet everyone's still using C++. Um, and it turns out there has, you just have to go look elsewhere for it. And so like a language like D is doing a bunch of the stuff that I like that was just like grating on me when I was working in industry, working on C++. Um, and then I go over to D and it's like, oh yeah, no, we had those problems too, and we fixed it in this language. Um, it doesn't fix everything. There are like little bits of weird corners. Every language has got their quirks, but it fixes so many of them and just has so many places where it's better for that sort of stuff that like once I tried it out a little bit, it was just like yeah, okay, this is what I'm going to use for sure. Um, and it was like stable enough and robust enough. And had a bunch of other, parts of it that were just really nice. So it just felt like C++, but they continued to work on it. I know that's being unfair to the C++ community. They have continued to work on it, but like when you're trying to like basically patch an old language, it's really hard to like actually get stuff done. But D is allowed to just like cut it off and say like, nope, we are breaking compatibility with C++. We decided to do it a different way. Like, you in C, everyone does strings with a bunch of characters and then a null terminator, and that's like a huge buffer overflow problem if or like a huge security problem because you have to run through the whole thing or to figure out what the end of your string is. We are changing that a string is a length followed by the thing, the characters, and that is going to break compatibility with everything else, and we don't care because we're a new language. We get to choose how we do it. And so it just gets to do that everywhere you wanted that to have been done in C++ by now, but they can't because they're forced into the way the language is currently being used. There's other, I mean, I'm listing a bunch of the things that are like minor inconveniences, but there's a bunch of like bigger things too. Like the standard library is much better in D than it is in C and C++. It's both saner and more all-encompassing. Like it has, for example, like what do you call it? Like a worker pool, like a thread pool built in. And that's the one that I use in my game for just like issuing tasks out to other threads. And so I just use their built-in worker pool because it works. They have all sorts of stuff built into the standard library. It's way more all-encompassing than C and C++. Um, uh, and they have so like one of the other ones that it does is like really way better compile time features. So it has like compile time introspection that is really good. You can get all sorts of information about your code at compile time and then use it there as you need it if you're doing it for like save games or displaying debug stuff to the screen, or there's all sorts of other places that comes up. Um, And so it's like way more feature rich and way more ergonomic to use than C and C++. It has really good compile time execution to the point where like their standard library has like regular expressions built in, which is a very normal feature in a standard library. But they have regular expressions that can run at compile time if you want. So we'll literally at compile time compile your regular expression into like this sort of bytecode that then gets executed at runtime. And you don't need to do anything. You just type CT regex instead of regex. And at compile time, it does that compilation because that's how rich the compile time features are. Like you can just write, giant functions that do all sorts of stuff that run at compile time. And it's no big issue. And so they've got all sorts of stuff that you can do like that, which is really nice. Um, yeah, there's many other things. But
When I imagine how you must have felt, like you worked 5 years in the AAA industry, game industry, and C++ on game engines, so you developed a lot of the knowledge and skills how to get around in C++, but yet you decided to work from scratch in D. So first of all, where did your D knowledge come from? And how did you adapt all the things that you were used to in C++, maybe some libraries or things like dependencies that you were using, and now you can't use them because it's D?
right, yeah. So at the kind of the fundamental like line to line programming level, C++ and D are very similar. like if you read decode, you as a C++ programmer, you will be able to understand basically everything they're doing. You will occasionally see something that looks a little bit weird to you, or a keyword that stands out. But you will be able to understand what's going on. It looks very much like C and C++. So a lot of the all of the programming experience in terms of how I tackled and solve problems in C and C++ translates over to D very well. And it's not like I had to relearn. It wasn't like switching from D to Haskell or something, or sorry, C++ to Haskell or something like that. It was a way, they're way more similar
Okay.
languages at their core. And so that helped a lot. In terms of libraries and other stuff, I mean, I just read lots of documentation as I needed in order to do stuff, and just figured out what their way of doing it was, and it was usually pretty sane and didn't take that much work to figure out the different way. And then it helps that I try to write my code in an extremely straightforward manner. And so I wasn't trying to reproduce a unique, things like shared pointers in C and C++, figure out the equivalent or re-implement them on the D side, because I just don't use shared pointers. I go even simpler than that. I don't have these giant spirals of dependency graphs and stuff for objects owning other objects or anything like that in the game. It's just very straightforward, just like systems allocate memory and then use it, and that's it. And so a lot of the kind of translating in my head or figuring out what the equivalent would be was really straightforward. And then D does have it has extremely good interoperability with C, basically trivial if you want to call C functions out in some DLL or whatever. And which is great for being able to still use game libraries. So I use things like fmod and imgui and other libraries like that. And I just do it through their C interface, and it's no problem. Like the Steam API, it's no issue because they provide a C interface. Um, and if they only provide a C++ interface, D has decent interoperability with C++. It's honestly really hard because C++ interfaces can be really complicated. So if they give you an interface function that's templated, then at the interface level, you have to instantiate a template in a way that's going to match with all of them. And that's really complex. It's not D's fault. It's really complicated to do if you're a different language. And if you didn't make the same design decisions, it's hard to make everything line up. But you have a couple of options. You could write your own wrapper for the C++ interface, just write a C wrapper, and then on D you interface the C wrapper. Or you can usually make things work well enough, just change a couple of little things, and then it has the ability to call into C++ and do the name mangling and all of that, no problem. It's really just if the C++ interface is complicated. So for PhysX, which is the physics library I use, it has a C++ interface and doesn't really provide a C interface, at least that I saw. And it uses inheritance and virtual dispatch right there in the interface. So I ask it for a thing and it gives me back a class, or an instance of a class that really is polymorphic over a base class that is their internal implementation. And it just assumes that you're in C++ and that won't be a problem. In D, it's a little bit of a problem because I have to make sure the V tables line up between the two classes. And you can do it, and I did it. I just had to very carefully go through and fix a couple of things. C++, for example, has you need to do virtual destructors, right, in order to not have crazy crashes if you're doing polymorphic dispatch and you have a destructor. D doesn't care about virtual destructors because everything is way simpler than that. You don't have to worry about that sort of thing. So it doesn't have an entry for a virtual destructor at the top of the V table. So all the V tables are offset by 1. So you have to add a fake function
Oh.
into the top to get them all to line up, right? And so there was no documentation for this. I just had to go in, look at the memory, look at the assembly, figure out where it's jumping, and be why the hell is it jumping to this other function and then handing it the wrong arguments? This makes no sense. And it's because the V tables are out of line. But once you figure that out, it's it works. I'm using physics in my game without much issue, and I only had to solve a couple of things like that, and then everything else lined up.
Okay.
And it's sorry, go ahead.
No, I just said, okay, nice. This is very impressive to figure out that you need a fake function to the offset of the V table to actually match the proper.
Yeah.
Nice, nice. When you say it interoperates with C very nicely, do you mean you generate bindings for it, or how does it work exactly?
Yeah, usually the way you'll do it is you would write bindings, but you could if you want, you can do that right in line in your code. Basically, D has a bunch of options for calling conventions and stuff. By default, it uses the D calling convention, which is its own that it made. And you can literally just write, I'm probably going to get this wrong. I think you write extern C, but I can't remember. You write some
Okay.
keyword basically in front of your function. And that basically tells it, hey, I want you to, when you're dealing with linking and compiling and stuff, I want you to use the C interfaces for everything. Pretend this is a function that got compiled in C. And so I can basically declare, like at the top of my function, if I want to just call some C function somewhere, I put the function declaration up there and I put external C in the front. And then when the compiler goes and calls it calls it using all of the C standards, and the C ABI, and the way that C functions normally get called. So it's really straightforward to do that. You basically just mark it as such, and D will handle any weird name mangling or getting the things to line up or the calling convention and all of that. It will handle that for you. And so if you're doing a larger library, usually you will put all of those declarations in one file, and that's your binding. Um, but if you want it, you don't even like it's so low effort to do that, particularly for C, that you could just do it like basically inline in your code if you wanted. Like if in your code you like load a DLL that is written in C, get the DLL, get a pointer, like get the address of some function within there, and then call it. All you would need is one line somewhere in your code to say, hey, here's the function declaration for the function I'm about to call that I got back in this pointer, and it looks like this. And by the way, it's a C function, not a D function. And then that's all it needs. And now you can call that function through the DLL.
Nice.
So it's really straightforward.
Nice. Nice. Uh, I'm assuming, given your background, that you work in a project and you have all of your dependencies listed as source files, right? You don't have any sort of package manager that would give you the libraries, right? You just have the source file directly linked as a sub project. Okay.
Yeah, exactly. D does have a package manager if that's how the way that if you're like programming like that. For games or like for a large project where I care a lot about the stability, I have never been that much of a package manager guy. And that's mostly just because when like on a large project, I want to get a version of a dependency, test it a bunch, and then pin it and never change it until I ship. Unless I have a really, really good reason to change it. And that's just for like stability, like updates can have bugs, and even if they don't have bugs, they can like change behavior in a subtle way that is perfectly valid for them, but I was assuming a different thing and now it's broken some assumption I was making. And so I just really prefer to, like, for stability reasons and for reliability reasons, I just keep those pinned. So I generally, like, if I find, even if it's available on D's packet manager, which I think is called Dub, if I remember correctly, um I just go to the GitHub of whoever provided the package, and I download like a version from GitHub and manually put a folder into my project somewhere and get it to build, and then link to it if I'm doing it statically, or otherwise I compile the DLL and link to it dynamically, and then like once I've got it in there, I commit that into my code base and leave it there forever.
I asked you, what, so you said that it's very easy to get into D when you have C or C++ programming experience. Does it mean that you started from scratch with D, with an engine, without prior experience in D, and you were learned along the way, or you had some sort of prior experience?
I pretty much did it with no prior experience. I had fiddled around with D just as like a very casual hobbyist about a year or two prior, I think, to me starting full time on my project. But that's it. And that was just like, you know, maybe 500 lines of code total of just
Okay,
trying
okay.
trying out a couple of the features. Like I wrote a little utility here or there or whatever, just like not very much. Um, but like enough to just try out the bits and pieces of it. But yeah, no, I didn't like have work experience or anything in D before. I don't know if work experience in D. There's very few like companies out there who are actually using it, and so it would be hard to get work experience in it. But it's so similar that like all of the low level stuff and the just language stuff that you learn in C and C++ will carry over really well.
Oh, I envy I don't even know how to say it. You have balls, man, to start game engine from scratch in a language that you didn't really use before. It's like, nah, I'm gonna ditch C++, hate the language. I'm gonna use something else. Have you ha- you're a 4.5 years into the project now, right?
Yep.
How do you see the decision to use D? Did it pay off?
Definitely. I am super happy with the decision to do that. Yeah, that 4.5 years for anyone who's listening should serve to you as a what's the right word? A something to keep in mind when you are deciding between engine and no engine. Because like I feel really good about the decisions that I've made and have a product that I think is interesting at least, and have built a thing and it's working well. And I feel good about all those decisions. Some people would be like 4.5 years, yeah, no way, I'm out. I need to use Unreal and get it done in 2 years. And if that's what's important to you, then cool, go for it. Like it probably would be the wrong decision to roll your own engine. And that totally makes sense. It's not gonna, like, the right decision is not the same for everyone. But in general, like, yeah, no, I feel really good about the decision. And the 4.5 years is primarily me rolling my own engine. I don't think it would be very different in C++. I think it may have taken me longer in C++. Because I would be wrestling with weirder stuff and it would just be slowed down by, a bunch of the other things. Like the learning curve was pretty easy in D, and the little tiny occasional bits of baloney I have to deal with, like v tables not lining up and stuff like that, um, were like way dwarfed by all of the other things that helped speed me up. Like for example, the D compiler is like blisteringly fast. The default one that they provide. I think when I started the project, it was like under half a second. And at this point in time, with 40 something thousand lines of code, I think in the whole thing, it's about 5 seconds for a rebuild. And so like, it's so like in when I worked in industry, it was between 5 minutes and 30 minutes for a rebuild. And like, to be fair, way bigger projects, right? Way bigger projects, like a lot more, much larger code bases. So it's not a fair comparison. Um, but like that really sucks. Like if I want to just like cry out a little thing, or I'm like, I think this bug might be a thing here. I'm just going to try changing this value, tune this value or whatever, and then I have to go get lunch with my coworkers before I can come back and try it out. Like that sucks. And when it's like 5 seconds to try stuff out, you just try out way more things. It's just such a huge, like, iteration time is king, and it's like such a huge boost to both your productivity and your happiness, to have good iteration time, as well as your, like, it's not even just like because it is faster to compile, you get, it's faster to do work. It is that. And then it's also just like you behave differently when your project compiles fast. Like like you will try things out that you wouldn't have otherwise. You would just, when there's less friction to try things out, you do things more. You test out different experiments. You try little bits of different things here and there. You test out what would happen if the lighting was actually cut in half or doubled or made this different color, or I changed this version of this thing, because it takes 5 seconds to try anything out. And so you just try it out. And like, that's really good for being able to find the best version of what you're doing. If it takes 30 minutes to try everything out after two attempts, you're like, I don't want to do this anymore. This is good enough. I'm stopping.
Yeah,
And then it's not as good as it could have been.
yeah, that's wild. That's wild comparison, by the way. Do you know
Yeah.
whether the compiler uses LLVM for the code generation or not?
So there's multiple versions of the decompiler. And I use two of them. There's one that uses its own custom backend. That's the one that's blisteringly fast. There's one that uses GDC as a backend, and one that's called GDC and one that's called LDC. And one uses GCC as the backend, and the other uses LLVM as the backend.
Okay.
And so I use the LLVM backend one for my release builds. It builds much slower than the other one, but also generates an executable that's, and in my experiments, it was more than 30% faster, compiling against LLVM than against DMD. And this is known within the community. This is like, what I am doing here is the common practice. It's like, for your release builds, you use the one that's backed against either GCC or LLVM, because they will do much better with optimizations. And then for your debug builds that you're just doing for iteration, use the DMD one because it's super fast. And because it's so fast, it's really good for iteration and debugging and, just trying things out.
Okay. Okay. That's awesome. That's awesome. Uh, Tell me a little bit more about the art of reflection. The game looks stunning.
Thanks.
And it's not a thing you would say for a person who's like, oh, I'm gonna build my own engine, like 3D renderer and also from scratch and a new language. Like, this is a lot of complexity built in, and to get to this high fidelity renders and style, it takes a lot of skill and knowledge. So congrats on that. Tell
I
me a
appreciate
bit,
it.
how did you do that? Like, where did you start from the development side, and what was the goal? What was the progress?
Yeah. I mean, so the overall progress from the early stages was way more meandering than it might look. The very first iteration of this game wasn't even this game, really. Like, right when I left AAA in order to work full time, at that time I was building in D, but the engine was 2D, and I was building a completely different game. and I was quite confident that that different game was good enough that I'd be able to bring that through to ship. And then I play tested it, and it was bad, and then I ditched it. Because like it just turned out the ideas that I had weren't really well fleshed out or good. They didn't work well. Um, and it was basically this like it was this old design I had for like basically like you are a like do you know what penetration testing is? So it's like the people who say you're like either in like military or like a large tech company, and you're like people are often trying to hack our systems. So they hire teams usually internally to try to hack their own systems to find the exploits. And so I was like trying to figure out this version of a game where like you could basically be a penetration tester for some large organization. And you both did technical stuff, a little bit of that, but you also did like social penetration testing, where you like walk in the front door and talk to the front desk person and see if you can talk your way into the building, right? And I thought that was a really cool idea. It turns out it's really, really hard to implement like conversation like that well. And I wanted to like have like an open text box that you could just type words into. And I built like I built a couple of cool things for it. Like I built this whole like pattern matching system so that you could like have like thousands of combinations of different wording for the same sentences, but only have to define a couple of them, and it would just automatically substitute it in parts and allow you to like pattern match intelligently. But like even with pattern match, that sort of pattern matching, like people would walk in, have an idea for what they wanted to do. Invariably, the game wouldn't have the same idea of what your options were, and it wouldn't work. And then they would try another thing, and then they would basically give up because like the game wasn't responding to what they wanted to do. Because there's just so many things you can try and do to like social engineer your way into a building. And so it ultimately, like I play tested with a few people and I just fell totally flat. It didn't work at all. And so then from that point, also a note about that is that what's really interesting is that I thought the open text box thing, which is like what the old like text adventures did, was like a really cool idea because it's like when you pick from a menu, like there's no sense of discovery if you pick something interesting. But if you have an open text box, you don't see what your options are. You really have to think through what your options are. And if you type in something that is like, I pieced together this thing that this other person said in this, and I actually think it might be because of this third thing that is part of the mystery. And if you think to do that, type it into the box, like confront a character about it, and they react to it. It's really satisfying. And that was like the goal that was in my head the whole time. And I stand by that goal, even if my attempt at it was a total failure. And it turned out to be a way harder problem than I thought. But games have done that since. So if you do you know the root trees are dead? So
No, I haven't.
it's a mystery game where you're like filling in the family tree, kind of following the death of a few people in this family and trying to figure out the mystery behind like what happened in this family. And the interface for it's a mystery game, sort of like in the vein of A Case of the Golden Idol, but just a kind of a different structure. But what they do for their interface instead is that you are using like an early 2000s era search engine, and you're just typing words into the search engine. So you'll like read a newspaper article that mentions the three people who died, and so you go over to the search engine and you look up their names, and then you find some articles about their names, and within those articles they mention other things, and you go into the search engine and you type in those things, and you find other stuff, and you eventually start piecing together like inferences between them and like do that in order to do your research. And that game uses an open text box. It just uses it so much smarter than I did, because if you type in a search into a text box and you don't find anything, your search engine just says sorry, no results found. So it's okay if you walk up to a person at a desk and you try to tell them like, hey, when is your birthday? And then the game has no response for you because I didn't program that in. That really sucks as a player, and so that experience doesn't work. And so the person who made The Root Trees Are Dead had the same idea and saw the same promise in the open text box kind of thing, and just found a way better implementation for it from a design point of view. And so hats off to them. They did the thing that I failed to do, which is figure out a way to use this in a way that actually makes a good game.
Okay, okay. Now because I assume this was pre-LLM, maybe with the LLM you could have a prompt that would have the, informations that you're trying to hack, like to get from the person, and then you could like bullshit your way for all the other answers, just giving random stuff and responses.
Yeah.
But this was very tricky to test and find corner cases, probably.
Yeah, totally. And it means that I think if you're doing that, you would ultimately have to be okay shipping a thing where you don't actually 100% know how it's going to behave in all the
Yeah.
cases. Because like you can't manually verify all the possible things an LLM would say back to you. So you just have to be like, I hope it's gonna work and it should be fine. But
Yeah.
it's an interesting idea. I think there's like design space to explore in there, particularly as LLMs keep getting better. But it wasn't the avenue that I went down, and they didn't exist at that level of quality. This
Yeah.
was 2020 when I started this, so like I want to say 2021 ish was like when like ChatGPT, like the first versions came out, and people like it started hitting the public eye of like, oh crap, these things are really like kind of impressive. Um,
So how did you start on the art of reflection then?
Right. So around the time when I realized that this 2D game was not working out, I basically I stopped working on that particular idea. And instead, I was chatting with a developer friend I have who I also worked with in industry, who was like a fantastic like kind of mentor sort of, and just like I don't know, partner to like bounce ideas off of and talk about like how you design games and how you make them good. Um, and I chatted with him a lot in that time and kind of like experimented with even just like drafting up some really, really early design documents. I'm not that big into like making really big detailed design documents. I'd rather just prototype. You get your answers faster that way. But like just writing down your ideas a little bit can kind of help like cement them and make sure you've actually thought them through. And so I was kind of just like thinking about different areas for the game to go. Um, and I bounced through like a handful of different ideas, never really pursuing any of them until I eventually landed on one that involved like you kind of being out in this forest and moving between these different log cabins out in this forest and like unraveling this secret that was like happening in these log cabins. And also there were these like I was trying to figure out a way to solve the open text box thing. So instead of being humans, it was like robots you're talking to, because it's more okay for a robot to say does not compute, I don't have an answer for you, than it is for a human. Um, None of it really made that much sense. They weren't like very good ideas in retrospect. I was just kind of like toying with them. But what I eventually was kind of designing in my head at the same time with that log cabin in the woods thing is like walking through a forest for a really long distance sucks. So I should probably give you like some sort of teleport between the different points of interest within the forest. And so around the same time that I did that, I played Outer Wilds Echoes of the Eye, um, which I'll try not to spoil anything, but there's a particular moment in the DLC where a thing happens that will look very familiar to you if you have played my game. To the point like people have called it out in YouTube comments when streamers play the game. They're like, "That looks like the thing in Echoes in the Eye." I'm like, you're right, it is. I played that right around the time when I was doing this, and like when that happens to you in Echoes of the Eye, it happens in a very different context in a different way than the way that I do it. This is like the kind of teleport dolly zoom thing. Um, and it happens to you as like a total surprise in Outer Wilds, just like the way Outer Wilds does all sorts of other things. It lets you discover it. So you basically just like shine your light on this thing, and then it just instantly does a dolly zoom, like it teleports you to the thing without telling you that it was going to do that. And so that was like this like really I don't know, that moment really stood out for me in the DLC where I was like, holy crap, that was a really like delightful surprise. I was not expecting that at all. And also, holy crap, that effect is so cool. And I was like, wait a second, I never like I knew what a dolly zoom is. I've seen it in like film and stuff. Dolly zoom is where you slide the camera forwards or backwards while adjusting the field of view at the same time to keep the subject at appearing to be at the same location. You can like go on YouTube if you look up dolly zoom, you'll find uh, like video essays about the effect in different examples from film. It's been used all over the place. It's not a new idea at all. But hadn't seen it very much in games, and I had never seen it used to execute a teleport. I thought that was super interesting, and that was what Outer Wilds did. And I was like, wait, if you vary the amount of zoom, don't you vary the distance of the teleport? And so once I did that, I went in and started prototyping it. And so because I was like, oh, I want to see how this works and just like try it out. Um, and so going on parallel to that, like during the time when I was doing the design doc stuff, I was also just building a 3D renderer um, out of like what I had from before from the 2D side and just kind of scrapping bits of the 2D and building the 3D part out. Um, Largely because there was a realization I was having, again, partly in part by like chatting with this the friend that I had from working in industry who was like he was like basically like a year to a year and a half ahead of me in terms of his progress through building games, and so I had just all of this insight and knowledge that he was able to give me, which was incredibly valuable. And one of the things he brought up is like, Lewis, you're a strong programmer and not so strong an artist. And when you make a 2D game, games need to look good to sell. Like that is the reality of it. Like if you look better, you sell better. And when you make a 2D game, you live and die on the quality of your art. There's a few exceptions, like a game like, for example, Noita relies a lot on like procedural stuff to like simulate particles to make things look cool. There's like a couple of avenues you can go, but like most indie games that are in 2D, like it's like they are relying on having gorgeous art. Like just 2D, like painterly hand drawn, art in order to make the game look good and having like a great visual style. And I don't have the skill set for that. Like I would need another 5 years to develop it. And it's honestly, looking at the Art of Reflection right now, if you go play the demo, it's plain as day that I don't have those art skills. Like it's one of the massive uh, drawbacks of like massive weak spots of the game right now. It's one of my huge blind spots. Um, but what the friend was saying to me was, he was like, in 3D, like you already know how to build a 3D render and you know how to write shaders. Like you know how to write code to make things look pretty, even if you don't know how to draw the art to make things look pretty. And writing codes to make things look pretty is a viable option. Um, and so that I've kind of just started. I wasn't necessarily fully sure I was going to do 3D, but it was enough for me to like start working on a renderer and just see what I could get done in a short amount of time and get kind of stood up and how hard it was going to be. And so I had a generally functional 3D render. It wasn't like PBR yet. It wasn't doing anything fancy, but it was there and you could like sit in a scene and move around it. And so once I played Echoes of the Eye, I immediately turned around and implemented the dolly zoom thing into Echoes of the Eye. Um, and it was really cool. And it turned out like, I was like, yep, you're doing different distances, does this, and different amounts of zoom make you go different distances. And then also, uh, I won't say it because it's a spoiler in my current game, but there's a different way you can, if you have played it, you'll know what I'm talking about. There's a different way that you can zoom things that is a natural extension of the way that you do it when you go forwards. um, and uh, if you do that, everything, the math works out perfectly, and it also works and looks really cool. And I've never seen anyone do that before. And so that emerged with basically almost no additional code. It's just like a natural consequence of implementing that mechanic was you can also do this. Um, and when I did that, I played around with that and it was really cool. And then part of the initial pitch in the design document that I had for the weird log cabin and stuff that I was slowly starting to get more and more removed from, and I realized that wasn't the thing here that was interesting. Was this idea that you could like set up mirrors and like go through the mirrors in order to make the whole zipping around the woods thing a little bit more interesting. But I didn't have any puzzles or anything worked out or ideas about what you could do with that. I was just like, oh yeah, you just like, if you set up a mirror, maybe you can go out into the woods and put a mirror here, and that will help you get to this other area faster because you can just zoom through the mirror or like bounce off of it or whatever. Um, and then so I started implementing that in the engine as well. Probably like I didn't have a clear game in mind at this point, so I don't like, maybe it wasn't like wise because I was kind of just going out of the limb and chasing what seemed cool. But I mean, to be fair, from what I hear, a lot of games start that way, from just like chasing what seems cool. Um, and so I was like, okay, screw whatever I was working on before that's supposed to turn into the thing that I'm able to sell. Like this is more interesting. I'm just going to play with this for a bit. And like implemented mirrors, which took a little bit of time because they're not the most straightforward thing to implement in a 3D renderer. But got that working and then set them up and then implemented the whole feature with you being able to go through them. And then once I was able to do that and see it in game, I was like, this is the game. I got it. Like this is there's so much cool stuff I can do here. This is obviously what I need to make. And all that other stuff, I'm throwing that out. I'm building out this 3D render. This is going to be a 3D game. That's probably going to make it take longer, but okay, I'm going to do this. And make the mirror rendering better. And it needs to be recursive so you can see mirrors within mirrors, because wouldn't it be really cool if you go through 20 mirrors all at once? And so I had to do a bunch of stuff with there, but like that was the point where it became clear. Once I had that zooming and those mirrors just like in an empty black room, basically,
Okay.
with a bunch of debug cubes in it. And then at that point, I was like, all right, this is the game.
Okay. How did you know that this is gonna be then puzzle game? Because you can have mirrors in all sorts of games, right?
That's true. I've even had playtesters play my current build of the game and be like, I wish there were more platforming challenges because this would be a cool game where you're like hopping on walls and like shooting mirrors at a wall using like a mirror gun, kind of like Portal, but you're doing it like as a like a precision platformer. And my reaction to this, I think that could be really cool, right? That might be a really fun game too. It's not the game that I'm making right now. Um, the I just play a lot of puzzle games, so I think it was the obvious way for my brain to go in. And like I mentioned before, like playing a bunch of um first person puzzle games, like playing like Portal and Superliminal and Viewfinder and The Witness and Outer Wilds, and like lots of games in that vein being like big, or Antichamber is another big one, kind of being big influences on me. And I just love those sorts of games. So like that was just the most obvious one in my head. And so it was the first version that I chased. And when I started chasing it and being like, okay, what interesting things can I do with this mechanic to create puzzles? Puzzles started falling out really easily. Like I did not have to go pushing really hard to start finding interesting interactions instantly. And that was enough for me to be like, okay, like puzzles are falling out of this thing, like basically everywhere I look. So this is that is a good sign for a fruitful mechanic that is going to yield like interesting things to explore. I also like the other thing was that I caught myself like just sitting in that empty room playing with a mechanic. Like I would just like put a couple of mirrors around and just like go through them and then go through them other ways and then like fall off the platform and then go like back up and over and then move the mirrors and then go through them in different angles. And I was just like I would sometimes just like lose track of what I was supposed to be doing and just be playing around for 15 or 20 minutes in it and then realize like wait a second, I'm supposed to be programming. What am I doing? And like I had a feeling that I'm like if playing around with this just for like if I'm forgetting what I'm supposed to do playing around with this, that's probably a good sign that this mechanic is like it feels good to toy with. It is interesting. It is like kind of mind bending in the way that I hope that it can be. And there's potential here. Um,
Awesome.
yeah,
Awesome. Uh, so how did you design puzzles? And were you removing puzzles at some point? Like, did you have a sort of like a difficulty curve? Like, how did you go around this?
yeah. I mean, this is my first time trying to actually design a game. I have um thought about game design for large portions of my life. I like like critically analyzed games, but that's not worth that much if you've never actually built something. And so this is my first time actually trying to build something. Um, and so I kind of just like tried to like follow the principles that I had tried to pick up up until that point that I knew from playing a lot of puzzle games. Um, and then just like build forward and see what happens. And so like a big part of my um like the philosophy that I tried to follow, which is not at all made up by me. Like a lot of other people who have made puzzle games before me have way wiser things and are the ones who actually came up with this sort of stuff. But like the idea of like knowing what your game is about and like what the kind of core mechanic or interaction is, and then the ways in which those interactions and mechanics yield interesting or surprising results, even just playing around in an empty room or a room with a couple of objects. Like, what are the interesting things that happen? And then can I build puzzles that force those interesting things to happen? um and so just like get players like I have like one way to kind of phrase it is that like I'm exploring this area of I don't know the universe where like pretend you can go through mirrors and all of these things emerge organically when you try and do that. And I have spent a few years now like bushwhacking through the undergrowth of this like dense forest, and every now and then I find like some really cool ruins, and then over here there's just a bunch of like um, poop sitting on the ground, and I just had to bushwhack through it, see it, and then go another way. And my goal is to, having spent a few years bushwhacking through here, to be able to now like lay down a path behind me and say like, hey, people, there's like this really cool thing out here in the forest, and I bushwhack through here so you don't have to. And over here is the really cool ruins, and over here is this beautiful mountain, and over here is this fantastic grove, and here are all the really cool parts of it. Like, come along with me for this ride, and see what I have seen when I've been playing around with this. And don't worry about the poop over there. You can ignore that. That part's not actually interesting. It seems like it might be, but it's not. Trust me, I've tried.
Okay.
um,
Okay. All right. Can you tell me a little bit more about the tech of the game, underlying tech? So, how do you structure the engine? What are the systems and subsystems that run through sort of like a technical overview of the code?
yeah. Let's see. Uh, I mean, so by and large, like some of what I kind of wanted to do in this project was like test some theories that I had coming out of AAA. um on basically like I mean like I learned a lot of really valuable stuff working in AAA and would never like do not regret it in the slightest. It was hugely valuable for me being able to like come into indie development like actually kind of knowing how to at least how to build an engine. Didn't know the design or the art or any of that, but the programming side I actually kind of knew. And so it was really valuable. But there's also like all sorts of stuff where I was like, I feel like the way we're doing this is overcomplicated, or I feel like why are we doing it like this? This is taking so much time. Couldn't we just do this? and I wanted to like test out a bunch of those things. And one of those things is just like you can get away with like a really really simple code structure, and you don't have to make all of these like a lot of really complicated systems for the most part. Like so like the main overarching loop for my game is like this, like I literally have a file called game.d, and it has like a small number of functions in it. It has like update, draw, handle events. And literally within update, like update is this function that makes about 50 function calls. It calls first person camera.update, zoom manager.update, um, area system.update, music system.update, music cylinder system.update, obelisk system.update. And it just goes like update, 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 update in whatever order I prefer. Draw does the same thing, handle events does the same thing. And like that's how the game gets all of the systems to do their thing. And then each one of the game systems, it's very like system oriented in a sense, where I don't want to add another oriented terminology to the world, like we that there's enough of them already. But like I basically just think about the game in terms of systems. And like I have a system is like responsible for handling some chunk of the game. It interacts with other systems, and that's okay. I just let them do that. Systems are they're not even singletons because they're not classes. They're all global. They present some sort of global interface that other systems can use as they see fit. They get to optionally, if they want, implement a handle event, a pre-update, an update, a pre-draw, and a draw, as well as an initialization and a teardown. And those are all of the functions that get called from game if you want. So basically, hey, whenever the game is doing an update, you have an opportunity to update something if you would like, or you have an opportunity to draw something if you would like. Um, and every system allocates its own memory, owns all of its own memory, gets to decide exactly how it wants to structure it or lay it out, whatever makes the most sense for that system. And it gets to decide what interface it provides to the world. And it can do whatever it wants for that. And so, like, if the interface is there's literally only one function you would ever call in here, then great. That's the only part of the public interface. Everybody else, everything else is internal. But if it wants to provide like some, for example, the entity manager allows you to look up entities, and then it gives you an entity ID, and then from an entity ID you can ask the entity manager, hey, I'd like the pointer to this entity, and it will give you back the pointer. And then when you have an entity pointer, you can actually read things on the entity. If you wanted to look something up, like, hey, I wanted to find the entity with this name, and then I wanted to find out whether it has this component on it, you could do it that way. And so in that case, the entity manager is allocating a bunch of entities, and it has this system for handing out IDs for them. And any user of that system or anyone who's interacting with that system uses that ID system in order to do it. But every system gets to decide what its interface is and how it does its memory, because the system just like figure out what it wants to do. And that's basically how most of it is structured. The different places or the different systems do somewhat different things, but most of them are like not that crazy. Um, they're mostly pretty straightforward. Like the only really complicated, like significantly complicated parts of the game are like a couple of spots in the rendering. Like the recursive mirror rendering is complicated because it needs to be fast, but the interface to it is not complicated. Nobody really interacts with the mirror renderer that much, with a couple of small exceptions. The mirror renderer just has like two giant functions within it inside pre-draw and draw. Um, where in pre-draw, it's like, okay, look at the current view and recursively find all of the mirrors and then mirrors within mirrors and build a big structure with all of the information you're going to need to be able to draw them. And then in draw, it takes that structure and then renders it out in the right order, and also generates a list of tasks and sends them wide so that it can run in parallel on multiple processors. Because it turns out, and you have like 200 mirrors on screen at once, it gets slow. And so you need to be issuing those draw calls in parallel. And so it breaks the tasks up, makes like a sort of estimate based on how many things are in each of the mirrors, breaks them up, sends them to different threads, runs those threads in parallel, and then submits them to the GPU in the correct order, based on how the order you needed to draw things in. That's
How
like sorry, go ahead.
how do you know which mirrors will not interact with each other if any mirror can reflect any other mirror? So you need to split the work, and there is no easy way to say what will never interact with each other.
Totally, yeah. So I steal. I mean, there's a let's see. So if you're familiar with the idea of like a culling frustum, which is
Yeah.
like the shape that sits in front of your view that kind of holds everything that you can currently see. And so I run before any of the mirror stuff runs, I run a culling pass, which also goes wide because it turns out you can parallelize that well. I run a culling pass for every single portal in the game. Um, and if I remember correctly, is that right? I forget so some of the code like I wrote 2 years ago and I've like forgotten how it works. But I believe I run a calling pass. No, I run a calling pass for every visible portal, I think is what it is.
Okay.
Um, I'm no, uh, I'm trying to remember what exactly I do because it's not every one of them because that's way too many of them. Um, but I run a calling pass basically for every portal that could possibly end up showing up on your view, so that every portal knows all of the objects that are in it and everything that's going to be rendering, including all other portals. Um, and it then uses that information over in the draw so that when it is looking at a given portal, it has the list already of what other portals show up in that view. I'm using the word portal here. I realize I have both portals and mirrors in the game. They're the exact same implementation. The only difference is you flip the view. Like everything else is basically the same. Um, and so internally, I called it the portal renderer because that's what I wrote first. But it's portals and mirrors, the same deal. But the portal renderer like then uses this list of culling things from the all of the different mirror views, which could potentially be like hundreds of them. So it might be culling hundreds of views and finding all the objects within them. Um, and then uses that list when it goes and walks them to know exactly what is within the view. And so it knows like within this mirror's view, which goes like this, there's actually only 3 mirrors that it can see. That one, and that one. And it also calls them out. So if they're facing away, for example, it doesn't take them. If they're like behind, like too close to you, it doesn't take them. There's like a bunch of other things that it uses to like remove them, um, to like reduce the number of mirrors that are getting rendered. And so it takes everything that is only within that view, and then on the next step of the tree, basically, if there were 3 mirrors in my view, we then rerun the same step on those 3 mirrors, and we go to that like inner mirror, and we move our camera around to pretend we're inside of that mirror now, um, and do the same kind of like the same pass again from there, and we keep going for some amount of depth until either we find nothing or we hit a max depth. The thing
Okay.
that ends up working out really well, that I mean, some of it was like I didn't know for sure that it would work out this way, but there's a technique that they developed that they use in Portal where if you imagine like standing in a room and looking at a mirror that's like a little bit away and kind of like turned to the side a bit, and you imagine like what can you actually see through that mirror. Like it's a pretty narrow field of view that you can actually see within that mirror. And so it's worthwhile to calculate what that field of view actually is because it's really narrow and that lets you eliminate most objects in the scene. And so when you do that, by the time, if you have organically placed mirrors, by the time you get like 3 or 4 levels deep, usually you can see nothing. Like, yeah, maybe this mirror that is at this angle saw a mirror over here, but based on where I am, I can't see it because the field of view gets like narrowed every time you go through a mirror
Oh.
at some angle. And so you end up usually not being able to see things. And so it just ends. Um, and in the portal renderer, I do a bunch of stuff to like try and catch those cases, right? Where like even if something technically was within the view frustum, I do like an oriented. There's a bunch of weird, complicated stuff, and I don't remember all of it. Every time I go back through, I'm like, oh yeah, I was like, I'm surprised I figured this out. This is cool. And like I do like an oriented bounding box check against the portal. Basically, like I place it there. I do the thing that you would want the stencil buffer actually does in the GPU. The thing is, I just have no way to get information back from the GPU without stalling it. Which is basically I want to figure out like if I was to render this mirror, is there a single pixel on the screen that would be changed by it? And if the answer is no, I don't want to render the mirror. It's a waste of my time. And you can carve off that entire branch of mirrors from that part forward, if that's the case.
Okay.
And so
Okay.
on the CPU, I try to do that. I don't do it quite as thoroughly as the GPU would, because it's the CPU and it's slower and it doesn't do things in parallel as well. There's probably ways you could do it, and I didn't do them. But I do like kind of a hacky like poor man's version of it, basically. Where I like check against like an oriented bounding box and a scissor rect and a couple of other things to see like, would you actually be able to see anything through this? And if the answer is no, this mirror is within the frustum, but it would not actually show up on the mirror, then I call it. And anytime you call a mirror, that mirror could have had more mirrors within it. So it's a huge savings to call out a branch of mirrors. And so I like really aggressively try to prune branches of the mirror tree, in
Yeah.
that way.
Okay.
And the only times that you really get like really deep reflections with a ton of mirrors are like very specific circumstances. Like if you set up two mirrors exactly back to back, they will repeat infinitely until you hit my render depth, which is like I think 16 right now or something like that. And they would keep going forever. And sure enough, if I set that render depth to like 64 or whatever, like I can very easily make the game crash just because it will just like keep going forever and ever and never do it. Or like a four-way mirror thing, kind of like this, is a really bad case as well. Where it just like
Oh yeah.
yeah,
Yeah.
every mirror hits every other mirror. There's no escaping the mirrors, and so you just keep seeing them on and on and on. And it looks really cool, but it's like a really bad performance case. Um, the one that's actually even worse, which is actually really bad in the game right now, is if you have two sets of mirrors back to back like this, because I don't do what's the right word for this? Occlusion calling. I don't do occlusion calling in the game. So if there's an object in front of a mirror, I still render the mirror and all of the stuff behind it, even though the object fully blocked it. It's just like there you can implement that, and I just haven't because there is a cost to having to look up those objects, know which objects are blockers, figure out if they actually block things, adjust your calling thing accordingly. And it hasn't ended up being so big a deal that I bothered to implement it, so I haven't. So if you set up two mirrors like this mirror reflects those two, and then each of those reflects those two. So you get this like exponential growth really quickly on the mirror hierarchy that really quickly becomes a problem. And so the other thing that I do in the game is I set a hard cap, I think at 256 mirrors. As soon as the game is rendered, it's 256 mirrors, it exits out. And it's just like, nope, I'm done. This is too much work this frame. We have to get going and get this frame out the door because this is going to be way too slow. And so if you like set up two spoilers, if you want to go break my game, if you go set up two mirrors like that, kind of in that configuration, then go into the middle and look at them, you will see the game. One, your frame rate will probably tank, and two, you will see the mirror recursion limit much earlier because it will only get like 5 or 6 deep before it hit that 256 limit and decided to leave. Um, and so like there are weird cases you can get where you can totally like overload the system, but for anything like below about 100 mirrors on screen, it usually ends up being just fine. And I was able to get it fast enough with a bunch of optimizations that it works out, and it's not that big or like it works out and isn't a crazy performance hog, only a medium performance hog. It also helps that on this game, rendering mirrors is like literally the only thing I do. Like the game's all about mirrors. So like if you're making GTA, right, you also need to be like running the crowd simulation and the vehicle physics and the weather patterns and like there's all this other stuff you have to be doing. And so you would get like a 2 millisecond budget to do your mirrors or something. Like, and 2 milliseconds would be very generous in that game. I have the full 16 milliseconds to do all of my mirror shenanigans. And so, like on any given frame, if you're looking at a particularly like mirror dense frame, you might be spending like 14, 15 milliseconds doing all of the mirror rendering on that frame, which would like that would get you laughed out of the room in AAA. Like they'd be like, "Are you kidding? 14 milliseconds? We don't have time for that." But my game is all about mirrors, so like literally, it's the only thing I do. Everything else in the game, like the physics sim, the player character update, the particles moving, all of that other stuff, it amounts to like 1 to 2 milliseconds max. All of the other time is available for mirror rendering. And so I get the luxury of getting to use more time for it, which is kind of nice.
Nice. How did you come up with all the optimizations and how to do it properly so that you can actually manage with the performance? Like, is this somewhere? Are there research papers that say do this, or this is just like your random trying things, understanding how this works, and trying things to actually get it?
A lot of it was trying things. Some of it was reading other stuff. I don't think there were very many research papers that I read, but there were definitely like, so there was like that talk from the people, the developers in my portal. I think it's actually part of like a Stanford online course. I could be wrong about that, but I thought there was like a online course where one of the lectures was given by the person who developed Portal, or one of the people who was on the tech team for Portal, and they talked about, for example, that frustum narrowing technique. And so I
Okay.
had seen that before I started this game, and so I knew that that was something that I should probably try and do. And sure enough, the difference between the implementation before that and after was massive. Like before that, I could get 3 or 4 mirrors on screen at once before everything tanked, and then after that, it was like 100. Like it was a massive improvement because it just meant you were drawing so much less. And then a bunch of so like that was somewhere I was very specifically cribbing from somebody else who had come before me and had figured this out. Um, And then there was other stuff that I just kind of tried haphazardly, or like I had some ideas of like I was just like playing around in the engine, like looking at mirrors, and I'm I like literally I can only see two mirrors here, but I know that it has to be rendering 100 of them because of how my setup is structured. That sucks. Can I fix that? Like, can I make it smarter so that it can figure out that it can't really see these things and could call them out of the render? And so then some of that was just like sort of haphazard, like, well, let's try this technique and see if it works. Oh, that didn't work. That ended up being slower. Okay, let's try this other one. And then eventually finding a few things that were like unilaterally faster. And then I just stuck with those.
Okay. Okay. Uh, I can't imagine again. I so admire your confidence. For you, like I can't imagine being in your place, being let's say 2 years in and making games about mirrors, and then realizing that if I put 3 or 4 mirrors, it's like top of my performance. This is everything I can handle. And now I just like I either find a way to make it happen or just like start a new project. It's like I can't imagine to be in this position. How
Yeah.
do you handle this, like stress wise?
I mean, like I never like solving the technical problems is fun and like the part I like. And it's also the part that I'm good at. Like it's all of the other stuff with like design and art and like uh marketing and positioning your product and understanding like what makes a good player experience. Like those are the things I'm weak at and I'm trying to learn at like on the fly as I make this, and I'm getting some of it right and definitely failing at other parts of it. The programming stuff is the side that I'm like relatively confident in because I did it for a bunch of time, uh, like when I worked in industry. And so I don't know, like maybe it's like naive, but there's a part of me that like when I put the mirrors on screen and I can only get three of them at a time, I'm like, I don't go like, oh no, I'm doomed. I go like, okay, how can I make this faster? I just like kind of crack my knuckles and I'm already let's get going. Let's see what I can do. And then maybe I'm gonna have to give up. So there are some things that are impossible for sure, but like I haven't tried everything yet, so let's try. And then some of it is also just like having an intuition from other games. Like Portal supported up to 8 portals deep, um, in the original Portal that came out in 2007. And like CPUs and GPUs are a lot better now than they were then. If I'm only rendering 4 mirrors right now, there's got to be something I'm not doing. Like I must be missing something because there's no way I am doing worse than Portal. Like back in 2007. It's not that Portal is bad. Portal is amazing, but like they had to deal with way different constraints and much poorer hardware in order to make their thing work. If they could do it back then surely I can do better today. And sure enough, there were things that I was able to do, but like some amount of intuition about like having an idea of how fast a computer is, and they are incredibly fast. It is hard for us mere mortals to understand how fast a computer is. We are often wrong about like our intuition about how fast computers is wrong by orders of magnitude, even experienced programmers. Um, and so just like knowing that and having a rough estimate for what I think a computer could probably get done based on other games and other stuff I've seen, I'm like, okay, like I don't feel like I'm fully utilizing the hardware here. There must be more than I can do. And then just try and explore and see if I can find what those things are.
Okay. Do you optimize on the level of SIMD and instructions?
I haven't had to yet. The one place that I thought about doing that was in the culling system, because the culling tends to be this extremely tight loop that you run on every single entity in the game. It's like the one place where every single entity currently loaded into the scene gets touched. And then once you touch it and decide, no, I don't need to draw that, you never touch it again for the rest of the draw. And that's the first pass on any given scene of like figuring out what do I even need to care about to start rendering this scene. Um, and so right in the very like middle of that loop, that like the culling system is something that is an example of there's a blog post that I read and I can't remember where it was, but like a well-known like rendering programmer person who wrote a blog post that was about like the kind of modern um, culling system techniques and how you can people have gotten it faster and faster over the years to like what the best implementation that he knew about today was. And I cribbed that exact implementation. Like I stole that verbatim basically into my game because of like somebody way people way smarter than me had been continuously developing this thing. I would never have figured that on my own. My like math skills aren't good enough, and so I just stole that and used it. And there is opportunity to possibly do SIMD in the culling system to just like because you're just dealing with like a swath of information on the CPU, and you're like, why not just check 4 objects at once or full 4 frustums at once, and which is a candidate for SIMD. I haven't done it yet because it hasn't been my bottleneck yet. and hasn't popped. Surprisingly, it hasn't popped up as the bottleneck in the game. When it does, I would consider it. But for now, I've been able to get away with just regular code and fast enough.
Nice, nice. I want to ask about something you mentioned. When you left AAA and started your own journey, you wanted to validate some of the ideas about, especially the complexity. And you found out, at least for the scope of your project, that it didn't need, it doesn't need to be that complicated. Looking back, why do you think AAA code is so complex? And is this a problem of the many people working together, multiplicity of teams, and the communication side? Is it more like knowledge slash, programming skills, stuff like that? Like, why does it happen?
Yeah, that is a good question and probably a really complex question. And I don't, I mean, I can definitely answer what I think the answer is. Anybody who really wants to get to the root of the issue should probably listen to a bunch of people in addition to me who also know what they're doing or have been in AAA much longer than I have. I am only one data point, and that data point will not be a complete picture. Um, as to how that sort of stuff emerges, it's probably like my best guess would be that it's a combination of things. So like at the studio that I worked at for the longest, the one where I basically learned rendering programming there, like they were founded in the late 1990s and have basically been building their code base up ever since then. And so they had an in-house engine that they had built for a long time, and they had rebuilt bits of the engine to modernize stuff here and there, and tried to deal with tech debt at various points along the way. But that engine has been shipping games for them for 20 years, and as long as you are actively trying to ship games, it's really hard to like stop and redo parts or stop and say like we actually realize this was a problem, we're changing our approach in the engine. You're kind of just stuck with what you have because nobody can slow down for long enough to like stop shipping games for 6 months or a year and redo stuff. um, and so there's that problem, which is that if you're always in shipping mode, you're never able to like restructure things as you learn better. um, there is, and then like the thing is, when you're building stuff as a programmer, I mean, maybe there are other programmers who are way smarter than me, that is always possible. But I am really bad at predicting the future when I'm writing code. And usually the advice I give to other programmers is don't try too hard to predict the future. Instead, like get started and keep your eye on what happens as you start building out the system and what you observe and what you learn. Like you're almost, I think it was I think if I remember correctly, Casey Muratori said this long before I did. But like in the early days of programming a feature, you're like more like an explorer than you are a builder. You're kind of like you don't understand the problem very well when you start, and so your first job is like you start building the thing, but you're really just starting to try to understand like what did it mean to build, build a system. I'm trying to build the particle system for my game, and like what are my needs, what are my constraints, what are my tolerances, what can I do and can't I do, what will work well, what won't. I don't know any of that when I start. And if I sit down in a room with a whiteboard and try to predict it all, I'm going to get most of it wrong. I'll get a few things right, and there are a few things that you can predict early, and experience will help you build those. But like you're going to get a lot of them wrong, and the you won't know them until you have finished building the thing, and then you won't really know them until you've been using it for a year, until the particle system has sat in the game for a year, and I've continued to build up the game, and I've seen, oh, actually, this is how these systems interact with it. This is what I actually needed. I thought I needed this. It turned out I kind of needed that, but I really needed this other thing. And so you get this a little bit of a loop where like you are expected at the start of a feature to lay down all of the architecture and all of the structure for what you're making, but that's the point in time where you know the least about what you're doing, and you have the worst idea about the code you're building. And I don't know of a way to break that contradiction. Like I maybe one day when I have 20 years of programming experience, like a light will go off in my head and I'll be able to structure everything right from day one. I don't think so. I think it's unlikely that that will happen. Um, or at least to me. And so the only way to do it is to get started and be ready to rewrite, right? And just like be ready to like learn as you go along the way. And I mean, we have a word for this in programming. It's refactoring, right? To like learn you as you learn how your code is used and what your real needs are and what the needs of maybe stakeholders or designers or other people are. You will have to change your code, and that's not a failure. That's normal. And trying to predict it all upfront is a fallacy. And the thing is that if you are building an engine over many, many years, um, and you are constantly, at least in low grade shipping mode, and maybe sometimes in high grade shipping mode, you're like trying to get games out the door to keep your studio afloat. Um, and you might, at year 4, learn that like actually this internal system we had isn't serving us very well because we thought it needed to be used this way, but it actually needs to be used this way. And so what we'd like to do is rewrite just that system to provide a better interface. But 2 games are relying on the system as is, and they are actively building features on top of that system as it is. And so we can't change it right now because it would break everything for those people. And there will never be a window in time where we're not shipping a game. And so it's really hard to find the time to do that. And then there's probably factors in that, like at any large studio, there are people coming and going at various times, and people of different skill levels. And so you'll skill level and different opinions on what good programming looks like. And so they will instill different philosophies into different parts of the code base, or sometimes into the same part of the code base, and make it a little bit of a mess. And some of those, well, there may even be cases where like both philosophies would have been fine, but combined they suck.
Oh yeah.
And they end up sucking as a result because different people were touching different parts of the code base, or the same part, or one person touched it for 3 years, then left the company. The new person came in and was like, "This is terrible. I'm doing it my way," and got it 50% of the way there, and then they left the studio, and then so it's kind of left in this like hodgepodge mess. And then through the whole thing, you're still trying to ship games on top of this thing. Um, and so it's a hard problem, I think. Um, and the thing that is like, I feel like it's important that I'm really transparent about is that I'm playing this game on easy mode because I am one person in my living room who can make unilateral technical decisions, like I'm building this thing not in C++. And I can just do that, and nobody will speak out against me, and nobody will be like, "But we already built the system in C++. We need to interoperate with that." And I'll be like, "Nope, I'm doing this." And that makes it easy. And so like, I don't want to pretend. I think it would be foolish for me to pretend that this experience as a one-man team gives me all the insight I need to run a 100-man team. That's just not true. They are different problems to solve. Um, but there are things even within that I did that we were doing on 100-person teams where I was thinking to myself, like, even on this 100-person team, I think we could be doing this a way better and way simpler. Or like, even on this 100-person team, our iteration time's 30 minutes. Like, we should not be tolerating this. We should be treating that as an emergency situation and throwing like 20 programmers at the problem to try to get our iteration time back. And like, that's how important I think that this is. But it was never given that importance. And so there's a whole bunch of stuff like that where even on a 100-person team, I've never run a 100-person team, so who knows? Might have no idea what I'm talking about. But like, where I suspect there was a better way, and we're just not able to do that because nobody can like unilaterally just like say like, everyone stop working on the engine for 3 months. I am slashing and burning this part of the code base. I'm rewriting it in a way simpler way. And then 3 months later, here you go. Here's the simple version. Rewrite all of the code you were doing to interface with this system, but now use this newer interface that's better, and go. And nobody can do that on a large moving project. And so you're stuck.
Okay. Yeah, the idea of having one engine supporting a couple of games that are each like shifted in the timeline, so you're never in this like breathing. You don't get any breathing room pretty much for the engine development. This is tough.
Yeah, totally.
But then again, I feel like you've made some decisions in the beginning, even though you didn't try to predict the future, but they were quite simple. It's like, here's an update. You will have a setup, you will have a teardown, you will have an update, you will have some sort of handling of events, you will have some sort of render. And then you forced yourself for each system to have, like, for each system to comply with the rules that you've set. And I wonder whether some part of this complexity in the bigger engines is that you start to break your own rules. You rediscover, oh, I have this new idea. Let's do this like event-based architecture. Like, let's not call functions directly. Let's do like event bus. And you lay it on top of the already existing ones, and you just keep doing this. And at some point, it's like 14 different ways to do one simple thing. And it spirals out of control.
Yeah, totally.
Okay. So what is the state of art of reflection now? How big is the code base? And what are your plans for the future?
The most pressing plan for the future is ship the video game, which I'm
Yes.
planning to do this year. Um, the Yeah, the state of the code base is, I mean, it's, I think I looked it up after when you sent me the question. So I think it was like 46,000 lines of code or so, total, not including external library code and other stuff that I'm calling into, just the code that I have written. Um, and yeah, I mean, like my short-term goals are just like get this game out the door, and like get this thing finished. I've been working on it for quite some time now, and I am eventually going to run out of money. I am like drawing down my savings in order to do this. And like at some point, like that money's going to run out, and I will have to go back to full-time work or something if I can't do this. And so, I need to get the game out the door, and so that's the most like imminent thing is just like finishing up all of the kind of the later levels, polishing based on feedback and stuff that I've gotten from playtests and people playing the game in the wild, and just like put all of the polish and the bows on it and like finish all the late game stuff, and design and write a couple other tracks of music and whatever that I need to kind of fill it out, and then hope that I feel ready to put this thing out into the world properly. Um, that's kind of the short term plan. Yeah.
Okay. Do you have plans for marketing?
Sort of. I have been doing, I mean, there's a fellow on the internet, named Chris Zukowski, I think is his name, who runs a blog and a consulting service as well. And I've followed his blog for a few years. He is basically the current state of the art in, hey, you're an indie trying to sell a game on Steam. Here's what you should be caring about. And he has a ton of really good advice. And so I basically am just following that advice. Um, and so like I am not actually that big on social media, like as from in my personal life to begin with. I haven't been on very many things, and so it's like a little bit weird trying to like have like a Twitter account and stuff, and like start shouting out into the void along with everyone else and go like, please notice me. um but I'm trying to do a little bit more of that than I have before. I've like sent emails out to streamers and stuff, and a couple of streamers have covered the game. um and I'm just like applying to just like any showcases or festivals or other similar things. I was in Steam Next Fest in earlier, it was like late February, early March. And that was really good. Like I got a huge influx of people playing the game, like more than double, than like more people played the game in that 1 week period than had ever played the demo before. And so like it was really good for getting a bunch of that, and therefore then like going online, finding a bunch of YouTube videos that people are streaming and like seeing them hit bugs and stuff, and be like, all right, cool, like you booted the game and you spawned into the end game level, and I have no idea how that is possible. I'm gonna go try and fix that because that should never happen. And just like seeing a bunch of stuff in the wild, or even if it's not outright bugs, but like design problems. Whereas like someone went into this level was supposed to be easy, and they did not see the thing that I thought I put really obviously in front of them. And they just didn't see it. And so they spent 10 minutes in that level, and it was really frustrating experience for them. And so then going back into the level and being, all right, I'm going to put a really bright light in front of it, and that
Yeah,
should
yeah.
solve that problem. And hopefully people will see it now. Or like, people who didn't see it before will now see it. Like it's just so hard to predict what of those things will come up. Like one that I ran into Next Fest that I hadn't actually seen before was, I when the player first walks up to a mirror and you can pick it up, I show a prompt on screen that says X or whatever your button is to pick up the mirror. You pick it up, and then I show you the prompt for how to rotate the mirror. And so they rotate the mirror, and then I figure everyone will remember, oh, you press the same button that you did to
Uh,
pick it up to put it down. But like 6 or 7 different people forgot how they picked up the mirror because I immediately was showing them 2 different prompts at once. It also happened right around the time they did their first zoom into a mirror. So there's like 3 or 4 things that they learn all in rapid succession. And for a decent chunk of players, how to put the mirror back down again fell out of their memory. And so like it just wasn't like all the other things. There's so much going on that it overwhelmed that. And so they were just stuck holding this mirror, and they're like walking around like, how do I put this down? And they're like trying to click and hit escape and stuff, and nothing's working. Um, and so I went back and I added a prompt. So I now show on the screen while you're holding a mirror in the intro area, it shows you how to put the mirror down. And there's like, I just would have never predicted that because I've been playing this game so long. I know the controls inside out. I am a bad judge of my own game's intuitiveness, because my head has been in it for so long. And so just getting fresh perspectives is like so unbelievably valuable for just seeing how the real world is seeing your game.
yeah, yeah. All right. Do you have any advice for aspiring developers who are now learning programming in the age of also AI and LLM tools? What worked for you? Who were you learning from, or which books you were learning from? What have you chased, and what really made you the programmer you are now?
Yeah. Um, like the biggest advice that I would give is like start programming. And that sounds like like really obvious. But like when I say that is that like when you're trying to learn a new skill, you should be spending, or even an old skill, a skill you've been doing for a while, like you should be spending at least 95% of your time actually doing the skill, and not watching YouTube videos, not reading articles, not participating in, like online discussion forums or communities, not reading books, not whatever else it is, but like actually doing the thing yourself. And that should be the first and foremost thing that you do. And then when you hit roadblocks, you can go look stuff up to try to like see if there's wisdom out there that might help you with this roadblock. Or if you want like passively in 5% of your time, yeah, go like chat with some people in an online community, go watch the YouTube streams from someone who knows what they're talking about. That can be really valuable. But the vast majority of your time, it should be you sitting at your computer with no interruptions, trying to program stuff. And then when you run into problems, try to work through the problems for a while. And then when you really run into problems, maybe go look some stuff up and see if you can see if there's help out there. Um, but something that I see so often is that ratio being kind of not like out of skew. Like I sit in some of the like Reddit the subreddits for like game development and graphics programming and stuff like that. And really common, I know this is like I get a biased sample by doing this because I don't see the people who are doing exactly what I just preached, because they're not on those threads. So I only see the people who aren't. So it's a biased sample. So that the sampling is not accurate. But you see people all the time who are like, what should I learn before I start programming? Or what should I learn before I start game development? And the answer is nothing. Start doing it. Like sit at your computer, open Visual Studio, start typing code and like trying to make a game. And it's going to suck, and that's okay. Just like make the thing. Like if you want to learn guitar, your first step is go on Craigslist, buy a cheap guitar, and then sit on your couch with the guitar in your hands and start making noise. And then like as you start to run into roadblocks, maybe you can look up a video that teaches you what a chord is, and you can learn a couple of your first chords. But like sit down with a guitar in your hands and start making noise with the strings of the guitar. It doesn't matter that it sucks, just start doing it. And then pick up information from other people on the side, because there's so much that can't be substituted by just doing the thing. That you can read all sorts of correct advice that is absolutely true and absolutely wise, and none of it matters if you don't have any experience putting it into practice, and you only get that experience by doing it. And so just like sit down and do it, and like have, I guess, an understanding that like the people who you admire who are really good at this got really good by doing exactly that, by spending a lot of time doing it. Like way more than you're expecting. Most novices at any field, I think, tend to vastly underestimate how much time an experienced person has spent just doing the thing and like failing at it repeatedly, or doing a crappy job at it repeatedly until they started getting better. Um, and so you're like the best thing you can do is just start. Um, and like don't try to be the greatest yet. Don't try to avoid all the possible pitfalls you can. Don't try to have the perfect technique going into it. And like it's really tempting to be like, I've heard that there's good ways and bad ways to program, and so I want to make sure that I do only the good ways before I even get started. Don't worry about that. Just sit down and start writing code. And that stuff will come in the 6 months, year, 2 years as you start going. And then on top of it, like if you don't have that experience and you're going on like you haven't really programmed that much yet, and you're going on Reddit threads reading about the good and the bad ways, you're just like blindly trusting people about what is good and what is bad in terms of programming. Like the thing is, the reason that these things are good and bad is because they have good and bad impacts on your ability to write code. And if you actually write code, you'll see that. And you'll be able to separate the good advice from the bad advice, because somebody will be like, hey, you probably run into this thing a bunch. You'll be nodding your head. You're like, yeah, I did run into that. And here's a way around it. And you'll be like, okay, I'll try it. You'll sit down, you'll try it, and it works. And you'll be like, wait, this is way better. It is way simpler for me to implement it this way. You're right. And then with the other person, you'll try it and you'll be like, wait, no, this is more complicated. I don't like this. Like, why would I do this? This has yielded worse code for me. And you'll just be able to like these are not, like good coding practices are not like decrees handed down on high that you're not supposed to understand, that you just, blindly implement. They're supposed to be things that really concretely impact, like the reason they're important is they concretely impact your ability to do the thing well. And so if you're actually doing the thing a bunch, you'll see the impact, and it'll be obvious to you what's working and what's not. So if I was to give like any piece of advice, it's just like start doing the thing and don't worry about what anyone else says. And if you can find a way to do it without getting judged at first, that might be good, because some people are like very averse to judgment. So if you are learning programming, that's usually pretty easy because nobody's looking over your shoulder at your early code. Just don't post it online for the first little bit. If you are tolerant to judgment and can deal with that, then go for it, by all means. But I know some people are really nervous about that. Um, and so if you're nervous about that, then yeah, by all means, don't like put your game on itch just yet. Just like make a little thing that you're happy playing around with. And then start building up from there and start really simple and just start doing it. Like get to the point where you're doing it as soon as possible, and you'll learn so much from doing it.
All right. Awesome. Awesome. I love it. Last question, because I almost forgot. What IDE are you using for D development?
Oh, I am using Vim. Just
Okay.
I'm using Vim. I'm using Visual Studio as a debugger with Visual D, which is a plugin for Visual Studio that lets you debug D code in it. Works great. Like lets you use all the Visual Studio debugger stuff, but it also understands like D arrays are, for example, different than C arrays, and it lets you understand all of those parts properly, and it all shows up in the debugger correctly. I literally have like a couple of build scripts and Vim scripts that I do. So like when I hit, for me, it's F6 over in Vim, it like automatically sends a message over to a Python script that's sitting in the background, and it's constantly like, um, uh, what's the word I'm looking for?
Calling?
It's speculatively building the game in the
Okay.
background. So like every time I save a change, it starts a build, just in case I might need it. And then whenever I hit F6, it flips over to that thing and says, "Hey, where you are in the build? Wherever you are in that build, finish it up and then swap it into the game." And then if I haven't booted up the game, when it finishes the build, it runs an auto hotkey script that changes focus in Windows over to Visual Studio and sends it an F5 to start the
Oh
debugger,
man.
which is like sort of hacky, but it totally works. And so it literally just like switches context over to that. So it's like my way of joining the two windows together because they're totally different programs. AutoHotkey is great for doing that sort of hacky crap. It's awesome.
Oh
Um,
man.
and so it sends an F5, which starts up the Visual Studio debugger and then runs the game inside the debugger. Um, so some weird mishmash is basically the answer of like my own Python build script, which basically just runs the decompiler, Visual Studio for debugging, and Vim for editing.
That's a nice setup, especially with the auto hotkey switching programs. I'm glad I asked. All right, awesome. Thank you so much, Luis. Shout out
No.
to Art of Reflection. For everybody who is listening, you can go to Steam and wishlist the game. And what platforms will be game available on?
Just PC for now. I would love to put it other places. For the time being, I'm just going to keep things simple for me, just being one person in my living room who's never done this before. And it'll be PC for now. If the game does decently enough, I would love to explore other platforms. And the demo is available right now, so you can like download it for free and try it out if you're interested.
Awesome. Luis, thank you so much. This was
Thank you.
a incredibly pleasant discussion, and I learned a lot. And awesome. You have so much
Yeah,
energy. I like it.
thank you. No, thank you so much for hosting this. I love this podcast, and it can be lonely doing solo development at times, and so it's so fun to just get to talk to someone about all this stuff that's bubbling inside my head all the time.
Great. Awesome. Thank you.